Hey, and welcome into Season 2 of the ProtoPod, the podcast for engineers, innovators, entrepreneurs, and trailblazers shaping the future. I'm your host, Jordan Rose. Today on the ProtoPod, we have Gladys Wong, co-founder of Domatic, a company reinventing how buildings are wired and smart systems deployed. Gladys leads the strategic vision, making smart buildings easier, safer, and more efficient. Also joining Gladys is Josh Horne, Domatic's technical and hardware lead, who takes the vision and makes it real in the field. Between them, they'll unpack how Domatic combines low voltage power and data on one cable, tackles real-world hardware constraints, and drives towards a future where every building is intelligent by default. Let's jump into today's episode. Welcome in, Gladys and Josh, to the ProtoPod. Gladys, the co-founder at Domatic, with a heavy focus on operations. Josh, hardware engineer at Domatic. Super excited to have you both on.
Thank you.
Good to meet you too. Thank you.
I wanted to just, start by getting an idea for what Domatic is and kind of the founding story of the company. I don't know, Gladys, if you'd want to tackle that.
Yeah. So basically, Jim and I, Jim is the CEO of our company. We were at Antimatter Research, which was a consulting business / incubator. So we were actually consulting on the side and trying to figure out what startup to get into. So we actually touched upon a lot of different startup companies, from holographic displays to, vehicle dash cams and that kind of stuff. So we helped a lot of different companies with their problems. But at one point, we got introduced to Ben He from Social Construct, and their company no longer exists now, but they were a YC funded company, and they were doing panelized buildings. And at that time, they approached us, hey, we need some help with, they wanted PoE, so power over Ethernet lighting. So they asked us to build a custom solution for them. So Jim was super excited about this because he's always had an affinity for smart things. Like when I first met him 10 years ago, he couldn't stop talking about, imagining everything being magical, like even umbrellas and things like that. Like he just has this very fantastic idea of making everything smart. So, and then the other thing is he revealed to me he has like 11 Nest thermostats in his home. For different things in his house, and so he's just completely like enamored by this idea, and I was kind of drawn into that too. So anyway, we ended up working for Social Construct for this building in Oakland. So it's actually live; it's a live building there. We did their lighting controls using the PoE solution. Near the end of that project, we decided, okay, this is it. There's a market here. People are willing to pay a lot of money for getting stuff like, intelligent buildings, because the existing power over Ethernet solution, there's some shortfalls. We basically, through that whole experience, we identified what the problems are, and we're like, okay, we could do better. So we got into Alchemist Accelerator, and just took a plunge from there. So we wound down the consulting business and started Domatic.
Interesting.
That was Genesis. Mm-hmm.
So yeah, all about power over Ethernet, and I know that you guys specialize in a single cable system that delivers power and data. I'm curious, you had mentioned some shortfalls in the equipment that you were trying to integrate in your kind of pilot project. Do you want to expand on what they are and how your technology looks to solve those problems?
Yeah. So basically, So we can look at it in terms of, like, we have fixtures in the building, like lights, door access control, sensors, that kind of stuff. They're all joined together to, at least with our solution, joined together at the hub. And then the hub is kind of like the backbone. So it gets stored in a closet somewhere next to the circuit breaker. And we can have many of these hubs connected just with normal Ethernet together to form like a super hub. So anything downstream from there, from the hub to the devices, is what we use, something called the Domatic cabling, which is a 2-conductor, power and ground. where we also run a communication over it. So this is basically, you can imagine it as like having like a Wi-Fi fidelity signal running through the copper itself. Since the copper is already delivering power, we're just kind of putting in the data onto the copper itself and have it so that all the devices can talk to each other in a kind of it's like in a Wi-Fi way, which is that they can all like we don't need one-to-one connections. They can all bombard each other and they'll resolve itself. Basically, it's I don't know if the audience knows about the power line communication. So we're essentially using power line communication, but on low voltage. So as opposed to traditional PoE, which is what the social construct building use, you need an Ethernet switch and server switch, and then a bunch of devices that are wired one-to-one. So imagine if you have 20 fixtures, you need 20 wires, 20 Ethernet cables going back to the switch. Whereas in our case, we have one hub. We can have one wire go out and branched and daisy chained to all the fixtures up to 100 watts. So basically, we end up with a much simpler wiring infrastructure at Wi-Fi fidelity. So it's running at like hundreds of megabits per second.
So far superior performance in addition
Yes.
to much more simplicity in installation, and that's kind of all
Yes.
powered by this idea that you don't need to resolve signals uniquely using a switch. Is that the idea?
Yes.
Interesting.
Yeah,
Very
that's the
interesting.
idea.
What has been, I imagine, these traditional PoE systems have been around for quite a while. I would imagine in developing something so innovative that there would be a lot of technical challenges. Could you kind of maybe jump into, you or Josh, what some of those are? What have been the biggest technical hurdles in doing that?
Yeah. So yeah, one thing that one of the benefits that Gladys said is we can run kind of any type of wiring network. So, it can daisy chain off another. We don't need individual switches like a typical Ethernet network. And so one challenge we've had is with crosstalk. So some devices, we may have, multiple wires on through a conduit off to somewhere. And with that, we can get some crosstalk. So we've had to develop some different ways of identifying, all the devices, on that network and making sure that, we're mitigating against that crosstalk. So that's been a interesting challenge that we've been able to solve and get past. So
we're being a little vague here because we have developed two proprietary solutions around how to deal with the crosstalk situation.
Okay. So without getting into specifics, really you're what I'm interpreting and full transparency here, I'm not a signals engineer, I'm not an electrical engineer, mechanical engineer. So this stuff is a little bit foreign to me. So you're really talking about contamination of signals from the wires being in close proximity, correct?
Yeah.
Yes.
And because we don't have a particular, for example, with Ethernet cables or RF cables or optical cables or things like that. They have more stringent requirements on shielding and where they get placed and different lengths. And since our system's a little bit more flexible, but I guess with that comes some challenges on that. But you could really run it over any wire that could carry the current that we need.
So that's actually go ahead.
Sorry, go on. I'm sorry about that.
No, it's all good. I was just going to say, so obviously that's a big separator for you guys, that technology. And you don't have to go into specifics, but I'm curious, that's a massive innovation, and something that we talk a lot about on this show is how the people we talk to and the customers that we serve drive their innovation, and especially when confronted with these highly uncertain problems that are niche or novel. So I'm wondering how your team kind of walks through these technical challenges. Like, is there any methodologies that you use in order to resolve these uncertainties and get to a point where you have something that works?
Can you repeat the question again? I kind of lost there. Sorry.
Yeah, it's all good. So I'm wondering, on the show, a general topic that we have is innovation, and how we at ProtoCase we like to think we help accelerate people's projects through providing them with quick turn parts, and it allows them to move with velocity and kind of get to their unknowns or their uncertainties pretty quickly. And in doing so, allows them to solve those problems faster, maintain momentum on their project, and get to the solution that they need. I'm curious as to, in a situation like yours, where this is a game breaker or a game changer in your industry, how you guys are tackling those really cutting edge types of technical challenges from like a project methodology standpoint. Like, what do you guys do to ensure that the signals aren't contaminated, without getting into specifics, the methodology of that? How do you guys work through it as a team?
We actually turn our office into a giant prototype lab. We basically run cables all over the ceiling and everything, with maybe 100 devices dangling from the ceiling. So we really, really stress the heck out of everything that we build. But I think the key thing is we need to be able to rapidly iterate, build prototypes quickly, and Josh has actually been very active on that front, like just spinning boards almost every week, just trying to get something out and having it tested. And one of the things is we rely on ProtoCase very heavily on the enclosure iteration. So in addition to testing the electrical pieces of the system, we also have to make sure that these things are a certain form factor so that it would fit in a building. And what we found is that there are various types of lights. There are lights where drivers sit outside of the fixture, and then there are lights where the driver fits inside the fixture. And then there are also other things like sensors, where the hole where you cut put the sensor into the ceiling or into the wall, that space, that cavity might be so small that you can't fit anything larger than like a credit card size thing. So we spent a lot of time thinking about form factor and just making sure that all these things would fit in all these different cases. And we have like a giant matrix of 2x2s, just like, okay, if it's too small, then it won't have enough capacity for power, because power is a function of how much heat dissipation, right? Like if you have a driver that is 90% efficient and it drives 100 watts, you're still dissipating 10 watts of power. Yeah. So there's this whole question around, or a whole problem around dealing with designing with those constraints. Like, okay, it's that small, but we need to drive 100 watts. Wait, but it gets too hot. How do we cool it down? And so I think maybe Josh can elaborate on some of the heat testing that he had to do.
Yeah. Just kind of going off what Gladys said. Yeah, I think just doing a lot of prototypes is something we lean towards, making just rapid iterations on the PCBs, enclosures, and also, like you said, kind of dog fooding the product in a way, is like using it, having it in the office or in our individual offices, and making sure things are getting right.
What about the potting test that you had to do?
Yeah. More specifically, yeah, one of our products being our LED drivers, which are one of our, you know, bigger products, just because lighting is one of the big things that you need in a building. Um, is yeah, getting the enclosures for those. We used to use like these off the shelf Hammond cases, and they just weren't like the right form factor, and so we ended up going with a bent sheet metal design um, that is pretty typical in the industry. But we ended up deciding to pot our drivers with. We initially used epoxy. We're now using silicone. Um, One of the reasons was because some customers will just install them like outside, and they're not supposed to. But that's a whole nother thing. Like how we deal with deployment. Like you know people are going to do exactly what you tell them not to, and they're not going to read the manual and all that. But um, yeah, dealing with thermal constraints of small LED drivers where we need to fit inside of these small sconces or these small lights has been a fun challenge. And yes, supporting all types of different lighting fixtures at different power requirements. So, anyways, I've my office has turned into a little bit of a chemistry lab at times where I've got thermocouples and probes, on all these devices, and I'm trying not to pour this epoxy onto my carpet, and kind of just baking everything along a table, and uh, I've got these giant resistor banks that look kind of scary, like bombs or something, and making sure I don't burn down the office with those as well. So, anyways, those have been some fun experiments.
No, I love that. I think it really touches on, again, something that comes up a lot on the show, and like that idea of the visual of having everything strung out on the ceiling, but the idea of doing whatever is possible, and you've illustrated that in so many ways. To use duct tape, as we would call it, to figure out what will work, right?
Yeah, because if we were more funded or more big lots of funding, we would have a dedicated lab space where we would do this kind of stuff, and we would have all this heavy equipment and all that stuff to do it. But because we don't, we have to use Josh's office to do some of the chemistry testing and the heat testing and the.
But it's a really great example though of the effectiveness of scoping down, and with more equipment, it doesn't necessarily come better results. It kind of comes down to the ingenuity of the person and working with what you have. The objective is to resolve the uncertainty that you have. The how you do it is somewhat secondary. So I think it's really cool, and a testament to your guys' creativity. I wonder, you guys. Oh. Go ahead.
Yeah, I was going to add that I know we mentioned a lot about LED drivers.
Yeah.
But we're not just driving LEDs. Like we're doing door access control, ventilation fans, different kinds of devices. So LEDs is just one of the challenges.
Yeah, exactly.
So once we work with fans, that's another challenge. With sensors, that's another one. So it's different problems all the time.
It's interesting. I know, in our own internal development, something that we find is that by scoping down and, maybe focusing on LED drivers, you will often learn things that you can use in, door access or what have you. And it kind of just speeds things up, but it's often transferable to all the other products that you're offering. So it's really interesting. I'm curious. I know that you had mentioned some issues with deployment, Josh. You're taking these ideas and these, innovative designs all the way from concept to reality and deployment. I'm just curious what sort of challenges you guys have with that, because it's a fairly wide breadth.
Yeah. I mean, I think, one of the challenges is in terms of just, commercial hardware, it's different than what you might do with like a simple, hobby Arduino project or something, right? Where it's not, it's in, pretty controlled conditions. So with our drivers and our hardware, for example, um, we've had to make sure, we need to make sure there's, voltage surge protection, current surge protection. There's, short circuit protection if things are, or, reverse polarity protection. So we have to assume that the, installers will plug things in wrong, they'll plug things in backwards and have, the necessary protections on our side. One, so we can, just not fry the devices. But also, one thing that we can offer is we can tell the customer, like, hey, like this is installed, but it's like not working right. And this is why. Whereas with, more quote unquote, like dumber technologies, you wouldn't know that. And you wouldn't, it might take you months of, popping off, ceiling tiles or something to figure out what's the issue. So we have, unique things on our drivers, like monitoring, the input power and the output power of the driver. So we can tell if, something looks like it's going to fail, or if there's, something going wrong with the monitoring of that. So, it's been a good challenge, just like making sure everything's robust, even things as small as like what the color of the wire is, because some people might be colorblind, and all sorts of things like that.
No, I was going to add that compared to a hobby product, this one goes into a building, and so based on the jurisdiction that governs buildings, and building inspectors are looking at, they're looking at building codes. The building code requires that the product needs to be UL listed. So going through UL listing is yet another thing that we have to deal with. It's a lot of money, it's a lot of pain, a lot of iteration, but we haven't failed any UL listing yet. So I think that's a testament to how good Josh and our previous engineer, our previous hardware engineer, like really nailed it. So basically we learned that with UL, that there is actually no state or federal laws around this. Like, it is really just the building needs it, the customer needs it, so that we have to go through the testing anyway. And then once we've tested it, the product gets listed. So we have to keep paying them to have the product listed continuously year after year. So I kind of think that it feels a little bit like a scam to me, but because we already know that we're going to design something that's safe. Like we know that, but in order for it to go into a database where it's listed, we have to pay money every year and have it, checked off, like, okay, it's done. So that's the extra piece of administrative stuff that we have to handle.
So how do you balance that, where you're continually innovating and trying to push the limits of what this technology can do? Like, how do you balance that with, what things you choose to list for people? I imagine at the end of the day, there's a lot of considerations. It's what the customer needs, what the client needs, and what their budget is. Like, how do you make that decision? Because it sounds like it's a tricky one.
For us, it's actually simple. Or for me, it's whichever customer pays money and wants it now. That's kind of the test, which is like if they're willing to go for a pilot project, turn it into a building, then we would prioritize the features for them, at least right now. So if they want, a really giant light, then we'll make it work for that giant light. If they really want a certain touchpad, we'll make it work for that touchpad. So it's entirely customer driven. And one of the things we do is we sneak in features into the drivers or into our cloud software. So we put all these features in, but we don't necessarily push the customers to buy it. We'll just kind of tease it out and say, hey, if you want this, we can turn it on. We can turn it on for you. And then that's kind of how we manage that, like, which is just get them in first. Maybe they would go with the lowest tier and then gradually kind of up them with like, hey, this month we release something. Hey, next month we release something.
Interesting. So more and more functionality kind of as they go, and more capabilities for their building.
Yeah.
Interesting.
And that is possible. That is possible now because, chips are becoming more powerful. We're kind of turning it into a little bit like the Tesla model, but not as extreme, where you make everything capable, like capability ready, and then when their customer's ready for it, then and when we're ready for it, we'll turn it on.
Interesting. So I guess that's a really great picture of where you guys currently are that you've painted, and I'm just curious kind of what's on the horizon. Like, where do you guys see Domatic in 5-10 years?
Ultimately, we want to be the custodian of this Domatic standard, because we've intentionally made this an open standard so that we want other people to participate. Like, we can see ourselves maybe continuing to make some of the hardware, but not all of them. We want the fixture makers to contribute. And we make that easy by just providing SDK, reference designs, and all that stuff. And we have a little module, which maybe Josh can elaborate on how we actually did it. It's basically in the future, it will be like $10 for this module. This module goes into a small module that can go into any fixture that you want to convert to be Domatic capable. And then we would, on our end, we would take care of actually having it integrated. So at least we want to enable the manufacturers to easily join the ecosystem without having to think about networking and IT and all that stuff.
Very interesting. Is there any, so that is on the integrator end. Is there any room for that to be implemented like in retrofitting, or is that of current buildings? Is that a silly question to ask?
So because we can run the Domatic network can run on any copper, we could technically run this on knob and tube too, like that. If you have knob and tube, but how we cut up the different circuits, we might have to do. So there will be some level of ripping out the walls and redoing the wiring. But it is possible to do it in retrofit.
Interesting. Very interesting. Well, thank you both so much. I'm curious if any of our listeners are looking to learn more about Domatic. Where would they find out more about you guys?
Well, we have our website at domatic.io, so domatic.io. And we have a LinkedIn profile where we, put blogs and things like that there. We don't have a very big social media presence right now because we found that this business is very relationship based. So all of our entries and approaches have been through, direct sales and people that we know. So I think at some point we would do a bigger push on social media when we're further along. When we're ready to tackle the masses.
Absolutely. Well, thank you both again so much. It's been super interesting getting to learn more about Domatic, and I can't wait to see what the future holds.
Thank you.
All right. Yeah. Thanks for having us on.
All right. Bye-bye, guys.
Okay.
Bye-bye.